Transformers leak oil, as is depicted in these couple of these pictures here, which are some rather drastic scenarios of such. And there's not only just bushings, but other different components can have oil leaks also. On the left, you see a sudden pressure relay, fault pressure relay, sometimes it's called, mounted on top of a transformer. This is a conservator style transformer, so the oil is all the way up in the tank. And needless to say, the flange on this device is failed. Customers made an attempt with some sort of external epoxy, and with the puddles around this thing, it's pretty apparent that they're fixed and work very well. In addition, these access hatches that are in various different places on transformers, 99% of the time below the level of the oil in the unit. And so it makes it a little bit of an involved chore to replace gaskets on those without draining the entire transformer to deal with. So how do you address your transformer leaks? Do you drain and regasket everything? One of my favorite pictures that I shamelessly borrowed from the internet several years ago. That kind of says it all. On a large power transformer, if you've got to deal with regasketing, you've got to take the oil all the way down. You need cranes to pull the bushings. You need people to assist in guiding that. You need tankers for the oil, and pretty involved process. So what are your different options? Very first option, do nothing. Well, the pros there is there's no repair costs, but on the con side, let me actually highlight the last bullet point there, the infiltration of air and moisture. Kind of a shout out to Drew in his presentation. I think it was in your second slide that you said that one of the greatest causes of moisture getting into transformers is leaks. So lo and behold, we can offer up a technique for you to contain those leaks, stop those leaks, to minimize not only your oil release issues, environmental issues, unsightly appearance, but also infiltration of air and moisture. So again, back to some of your options here. You can replace the entire transformer. Great, now you've got a new state-of-the-art unit and you can restart your remaining life cycle, but it's a pretty labor-intensive exercise. The outage can be measured in months, pretty costly. And I'm understanding, I think Drew alluded to this too, lead time on getting large power transformers these days is now apparently in an excessive number of months, probably even longer than a year. So replacements have got to be planned quite a bit in advance. You can, as I mentioned, you can regasket and replace all the leaking components, which should restore your transformer gasketing to a like new condition. Again, pretty labor intensive. You've got an outage you got to deal with, and again, pretty costly because of all the labor and effort to do that. And I'm also going to show you further on in my presentation a couple of scenarios where customers had regasketed a transformer and just about ready to put it back in service, and lo and behold, they discovered a couple of small components were leaking that we were invited to come up with solutions for them. And lastly, we talk about online leak seal, which is what we're going to highlight in the presentation today. The advantage here is you can have repaired gaskets to like new condition. Many repairs can be performed with the transformer in service. The duration of these repairs is usually measured in hours or days. And in reality, maybe you only address the ones that are leaking at the time, and have multiple visits by a leak sealing outfit to address them as they occur, as opposed to taking the entire transformer out and doing everything all at one time. The only con here, and I don't really want to, in reality, this is even a slight exaggeration too, repaired gaskets versus new gaskets. And I'll get into this a little bit later. The regasketing material that you lose for these leak seal techniques is in essence identical to the typical nitro rubber gaskets that are used in the industry. So in summary, so what are your options? You're going to drain and regasket, or are you going to use one of our repair techniques? What's depicted in the picture here is an external clamp going around a flange that was leaking. on a fairly large transformer. Actually, this was at an IPP plant. I think this was a 138 kV bushing turret on a transformer at that facility. So anyway, moving on. We're going to talk first of all in this online leak seal arena here. The first commonly used technique is what's referred to as a drill and inject repair method. And this is basically as simple as merely finding the gasket groove, which we've got the skill and experience to do, and drill access points to that, access holes to it, and tap those, and then pump a liquid sealing compound that cures to the same properties as a gasket into that gasket groove. Going back to this picture real quick, we talk about online, because this leaking flange is down at the bottom of this transformer, the odds are about 100% that this transformer was humming in this technician's left ear as he was performing this repair. So here's an actual photograph of what that graphical representation looks like. Here we're injecting the sealant compound into that gasket groove at the 12 o'clock position with our injector valve and the sealant coming from the small pump. And to track the progress of this sealant being injected, we drill multiple holes going around the clock face, as we would call it. So as we're injecting at the 12 o'clock position, you see we're monitoring for the sealant coming out of holes that were drilled at the 1 o'clock and the 11 o'clock. Likewise, there's another hole drilled around 8 o'clock, and we'll work our way around that gasket groove circle with multiple holes to inject and also monitor it. And then those holes they're threaded, they're tapped and threaded so that we put pipe plugs to seal those off to contain the sealant into that gasket groove. Another picture of multiple injector valves in place going around the gasket groove on another style of a radiator flange here. Just a little pieces of rag just tucked in there to contain the drips and keep the work site a little bit neater and cleaner in this situation here. And on occasion, we can drill and inject into a gasket groove on a bushing. Not only just flanges, but even on bushings if it's the right type of configuration. Just to highlight, many of the repairs, particularly on the lower end of transformer radiators and pumps and piping, can be performed with the transformer in service. Here's a cutaway view of one of those flapper valves. That was where we were doing the drill and inject. And actually, the next slide kind of shows this too. But you can see the black arrow is pointing to that gasket groove that we're going to locate and drill into. And in addition, we can also drill and inject the sealant compound into the valve packing area. Because sometimes you'll get the packing on these will begin to fail. And we can inject into there to contain the leaks. And the sealant is flexible enough that it's not going to disable the functionality of your valve, as you'll still be able to operate it. And here's a picture going into that valve packing area, that valve stem area on the left, and there's another injector valve going into that gasket groove on the right hand side. Showing how we would do that at both these locations. Another one, and you can see the holes here. In this one, they had traced a guide, probably with a magic marker, where the gasket groove interior side was, to assure that the holes that we drilled were away from that the interior side, away from the actual oil line in that flange. And just to highlight, leaks on the upper end of radiators and the bushing flanges usually require an outage, primarily for safe work clearances for the individuals performing the work. But again, can be performed in just a couple of days, and there's really no wait time prior to restore. Although we do like to leave the unit out of service overnight, just to make sure everything's cured up and we don't have to go back and reshoot something, which we have to take another outage. So you saw this picture earlier, but just to highlight, to make these repairs on those bushing turrets, and also if we were going to do the drill and inject into the flanges on those radiators, the top radiators, or some of the other piping on this transformer, we would need to get an outage for safe work clearance from the energized conductors that are above the heads of the technicians doing the work. The other repair technique that we use quite commonly is what we call the external clamp technique. In those installations where the drill and inject is not a viable solution, we can apply an external clamp to the flange that's fabricated in a precision fashion of aluminum, and it's finished to precise dimensions to fit the specific component that's leaking. These clamps are created based on measurements taken in the field, and we have several fabrication shops that can fabricate these for us and ship them to the work site, often in a day or two, from various locations around the country. And here's a view of an external clamp that's being prepped for installation. You can see the groove that the sealant compound will get pumped into in the same fashion as we would do into the gasket groove on a regular flange. The black rubber is just a cushioning device to help hold that clamp up against the component that we're sealing, and just a cushion so we don't have any damage, and it keeps it from moving around. In addition, this is just another style clamp over here to give you an idea that we can fabricate them in various and sundry sizes and shapes depending on the component we're going to enclose around. Graphic representation of what this looks like. Very common leak situation is this grout or gasket material that's between the porcelain and steel on a bushing that will develop leaks, fail, dry out, develop leaks. And this shows you how we would put the clamp around that bushing. And here's an actual photograph of a clamp in that same orientation where that would mount onto that porcelain steel interface. Here's a completed clamp. In this case here, instead of having the ears that stick out where the bolts go to hold it together, this one had a recession that a threaded rod with nuts goes into to pull the two halves of that clamp, and we just fill that with an RTV type caulk to just fill that cavity, make it look a little bit better, keep the spiders and moisture and such out of there. And we'll also shoot a bead of a RTV sealant around the perimeter at the top of the clamp when it's accessible like this, just to minimize moisture intrusion into there. Those access hatches, you saw that picture on the left, and the picture on the right is an access hatch that is at the base of a bushing pocket on a large transformer. And you see where the clamp has been put in place, and the technicians are pumping the sealant compound into that clamp. And again, there's a very good possibility this transformer was out of service. I mean, energized, was very much in service, energized at the time that this work was being performed. And it's down at ground level. We're far away from the live components up on top. Here's another butterfly valve or flapper valve with an open face flange that you can't drill and inject because of the open face configuration there. But in this case, we designed and fabricated a big three-part clamp to go around that flange that you can see in the photograph here and prep for going into place. You can see the holes, a couple of the holes that have been drilled here for the sealant compound to get injected in to that cavity. Once that clamp is in place, there's your clamp in place, and you can see those holes for the sealant to get pumped into to effectively contain those leaks. Here's that clamping fabricated at the one machine shop that we often use that's here in suburban Chicagoland. CAD design put into their CNC machines, and then they machine this up for us to get it shipped out to the site. Here's that sudden pressure relay that I showed you earlier with that leaking flange. And here's the clamp that was created to contain that leak. One thing I like to point out in this picture too is notice the snow that's on some of the other panels up on top of this transformer. So it was a bit chillier when this repair was actually done. And it kind of gives you the clue that this work can be done both warm weather, summertime, cold weather, wintertime. Biggest limiting factor really with the cold is just the extreme for the poor technicians doing the work. But weather does not, summer, winter, hot or cold, the same repair technique is applied. Just another view, another angle of this clamp. And this one here, you can see the injector valve, and you can see one of those pipe plugs that's been partially screwed into one of the holes on this clamp where the sealant's gone in. And you can see the injector in place, pumping the sealant into the side cavity on this guy right here. The sealant material is of the same geometric properties as nitro rubber gaskets, as I kind of mentioned earlier. This repair technique uses only one type of sealing compound, as opposed to high pressure industrial leak sealing, which may have different sealant compounds depending on the temperature and pressure and material that may be flowing inside the piping that's being addressed. So the technicians doing this low pressure seal technique in substation facilities don't have to be chemists. They don't have to determine what the right stuff is to use. There's only one type. Cures in a matter of hours, and the apparatus can be returned to service immediately after repairs. Again, like I say, we like to leave it out overnight to make sure everything's cured up and it's all good. Now, if the sealant does migrate into the transformer tank or oil-filled cavity of a bushing, it will not react adversely with transformer oil, nitrogen, or SF6, the fluids and gases that are commonly used in electric apparatus these days. Now, if the repaired component does require disassembly or removal, the cured sealing compound is always soft and pliable. It never hardens. In this case here, this is obviously the clamp normally stays in place, but there was an opportunity. This customer had a desire to take these clamps off for various and sundry reasons. And we came out and took photos and helped take the clamps off. And you can see it doesn't adhere on the inside. It's not a major chipping exercise to chip that stuff out of that clamp, nor is it a major exercise to chip it away from the actual component itself, the bushing itself. It easily cuts away, even with a pocket knife. And you're looking, so what's that funny meshy stuff there? Well, in this installation, they had put a piece of fiberglass mesh around the perimeter of the bushing there, just to help hold that clamp in place so it didn't hike up as the fluid, the sealant compound was injected into it. And again, that can be easily cut away if need be for whatever they might be doing. I've got some pictures of some other kind of different repairs aside from the traditional piping flanges and bushings and such. Some other flanges on transformers to get your creative juices flowing, your thoughts on where else this can be used. You've got those big flanges that go around the perimeter of an LTC compartment. This is a 40 MVA 138 to 12 transformer. The only records I had was this transformer was installed in 1993, and this repair was done about 2 years ago. And I would imagine this transformer was new when it was put in place in 1993. So it gives you an idea of the life of the transformer, and the fact that that flange, that gasket there, is probably at that point that it's time to deal with it and address the leaking. So instead of doing a major overhaul and taking that LTC off to regasket it, we designed this big clamp to go around that perimeter for them. This was designed in 4 pieces, mainly for ease of handling and limitations of the weight. And you can see the ears at the splits on the 4 components there on that. The other thing, I guess maybe I got the next picture. Here we go. In addition to the clamp, once you put the clamp on that flange, the oil is going to migrate to those the holes where the nuts and bolts go together to hold those components in place. And we will replace the nuts on the back side of the bolt hardware there with a hollowed out sealant type nut that you can pump the sealant compound in also. Like I say, the oil is going to start to migrate to other places. This is also a very common fix used on SF6 repairs too. Radiator drain valves, kind of a nuisance situation, as I term it here, that these can develop leaks and make a nice gooey mess in your drain rock. And we can fabricate a clamp out of just a little aluminum box to go around that. Put an extension on the drain side of that to allow you to continue to use that valve as designed. And all you have to do is just enclose around that valve stem area to, and you make that tight enough that the oil isn't going to infiltrate out. Of course, it's filled with the sealant, so yeah, you're going to effectively contain those leaks. Radiators. These flat style fins have a propensity to develop leaks with time, where these stiffeners make up to the fins, and we can fabricate a clamp as we're showing on this radiator tube, different style radiator, to effectively contain the leaks on the flat fins also. So you're looking at this and saying, yeah, great, you're showing a picture of around a tube. This is a flat fin. How do you fix that? Well, this one merits a full screen photo, is why I put this one separately. But basically a clamp that's in a C-type configuration, and the threaded rods run to the other side of that fin with just a backing plate there to hold that tight up against that fin. And here's a case. This clamp is fairly weathered, so it's been in place for a while, and depicting the fact that this has been effectively containing that leak on that radiator fin for quite some time. Another interesting challenge is some of these smaller transformers. This was on a 34 to 12 or 34 to 4, probably a 6250, 5000 kVA type transformer, where the radiator flange is in a rectangular type configuration as opposed to round. There's not enough work clearance to get in and do the drill and inject. That's not an effective solution here. So we were able to fabricate a clamp to get around the back side there, fill that with sealant compound, and effectively contain the leaks on that guy. Pumps, your larger transformer, your forced oil cooled transformers with pumps, as opposed to taking the pumps off, getting them refurbished and rebuilt. We can do a clamp around some of the flanges on those that will develop leaks. And here's two little repairs that we did. I know for a fact, because I personally took these photographs, that this transformer was in service when these repairs were made. They probably turned the pumps off one at a time for the work to be done. And upon completion and everything curing up, you can see in this one here that the flow gauge is in the pump on oil flowing position. On that one. No load tap operating shaft and handles. Where that operating rod penetrates into the transformer tank, there's a bushing of some sort with a flange that can develop leaks. And in this case here, we were able to take advantage of that faceplate and build a little clamp to put behind that faceplate, use a jack bolt to push it up into place, fill that with sealant compound, and effectively contain the leak on that. Now, in those situations where you don't have a faceplate of this nature, we have made just a clamp that would go over the entire no-load tap mechanism handle and cap on the outside. In a case where it isn't going to have as big a handle on it here, that would effectively contain the leaks. And in that situation, if you do need to go back and change your no-load tap, we can come out, take that clamp off, allow you to change that no-load tap, put it on the position you want it. We'll reinstall the clamp and refill it with sealant compound for it. This was a fun adventure. This was a huge GSU transformer at a hydro plant up in northern Ontario, I believe. And the manufacturer had an issue shortly after this unit was installed, that they had a weld fail actually inside this vertical stiffener. And their traditional repair would have been to find a way to take this unit out, take it apart, and re-weld that that area there, which is a logistical impossibility. So they invited us to come out and come up with a solution, and we found that we were able to put our stiffener, or I mean, sorry, put our sealant compound into this vertical stiffener here. But instead of filling the entire stiffener with sealant compound, we went up as high as we could with sand. You know, we drilled an access hole down where we could get to it, fill it with sand as high as we could go, and then fill the rest of it with the sealant compound, and then capped and plugged this this opening here to effectively contain that leak. To the best of my knowledge, 4 years later, this leak is still been solved and no longer a problem for this customer. Here's one of the situations where a utility customer had just regasketed this transformer. This is like a 345 to 138 transformer in a transmission substation that they had just finished regasketing it when they were about to put it back in service. It was July summertime. The operations folks were crying about getting this unit back, and as opposed to taking this thing out and replacing this butterfly valve, they called on us to come up with a solution. It was oil was working its way up through the the valve stem here, and our guys came up with this design to effectively contain that leak. And you can see that cylindrical clamp in place on that butterfly valve operating handle in the picture on the right, effectively containing that leak. Another fun story, back last fall, this is a generating station unit transformer that the prior unit catastrophically failed. And upon putting the replacement unit in place and putting it in service, once that unit got up to rated power and temperature and such, this fill valve here started to leak. And they didn't want to take the unit down for obvious reasons at a power plant to make a traditional repair on that. They would have had to bring the oil level down to do that. They called on us to make a box clamp that we fabricated and designed in an emergency around the clock basis to cover up that fill valve. And you can see the picture in the right there for that repair. Again, pictures in the dark because this was an emergency around the clock repair that we did from invitation to completion in about 3 days. Dresser couplings commonly used on larger transformers. We can make a clamp to go over those and effectively contain leaks with no problem. CT penetration, CT lead penetration is going into the main tank. Here's the hockey pucks, as they're referred to sometimes. That the gasketing on those has a propensity to fail, and you can see the oil running down from the one on the right there. And in this situation, we will fabricate a clamp made out of a PVC material, hollowed out on the inside, to put the sealant up around that component and contain that leak. Again, we'll use PVC as opposed to aluminum in an area where you're dealing with energized components that putting aluminum in there could compromise the functionality of those. Here's a finished picture of the two clamps in place, pumping the last of the sealant compound into the one on the right there. Another one of my favorites. This is a ancient 12 kV to 480 transformer that was serving load at a manufacturing plant here in the Chicagoland area. And I love the picture of the nameplate. I don't know the exact vintage of these, but this facility was built for or these transformers in service, and these are original transformers for building aircraft during the World War II effort. So these bad boys have been in service since then. 480 volt bushings with gaskets that are failing. Probably original replacement components are not to be found. And again, they didn't want to have to bring the oil down to work on these. So we fabricated PVC clamps to go around each of these 480 volt bushings to effectively contain those leaks for them. Oil circuit breakers leak just as much as transformers do, and they've got very similar components. The most popular leak, you might say, is this flange and interface between the porcelain and steel. You can see the leaking bushing on the left, and you can see the clamp in place in the one on the right to address that situation. Here's sealant compound getting pumped into that bushing clamp on this breaker here. Notice the next pole over has got another clamp in place. Again, effectively doing the repair there. We got invited to take a look at a situation here. This is a 138 kV oil circuit breaker, 1973 vintage breaker, and the voltage tap receptacle was starting to leak. And notice the old clamp that's on that interface area above that voltage tap. And judging from the condition of that clamp, that was put on quite a while ago, and that's still effectively doing its job too. But 1973 vintage, we, working with the customer, determined that we could identify that this is where the leak was. There's little gaskets in there, and this is where the leak was. We found by taking the cover off that, we could inject the sealant compound into that cavity and then put that cover back on and effectively contain that leak for them. Jumping to SF6 apparatus, kind of briefly here. This picture tells a couple of stories. It's an older Westinghouse SFA breaker, and it's an older photo. The gentleman using the leak detection camera there, an older style camera, is not wearing the typical PPE that you'd see in a substation today. So this was from quite a while ago. And it says, as long as these breakers have been in service, they've been leaking. As long as they've been leaking, we've been addressing those leaks for the customers with such apparatus. And another one, these are even older. This is a 1965 vintage, I believe, Westinghouse SF breaker that it just amazes me the number of these that are still in service around the country. We have worked on putting clamps on bushings on these, both on the West Coast and over in Pennsylvania. So there's a number of these old guys that are still successfully in service. Again, the Westinghouse SFA, the columns on these, the gas-filled columns on these, have a tremendous propensity to develop leaks, and we've designed clamps to go around the bases on those to address the gas leaks. EHV single pressure newer vintage breakers. There's again another steel to porcelain flange up here. Kind of really tough to make these out. It's in the shadow there, but there is a clamp that was put on up there, filled with the sealant compound to contain the SF6 from leaking out on these guys. Some of the newer lower voltage breakers, a lot of small instrument piping. We have built little box clamps similar to what we would put around a radiator drain valve to contain leaks where these fittings have a propensity to develop leaks. Dead tank style breaker with a flange going down the middle. We put clamps around those to contain those. This is another case study, and I highlight this with a lot of detail, the Siemens type SPS breaker. One particular customer has a number of these that have developed leaks that they've asked us to address. And with doing our research, our due diligence, looking at drawings on these things to get good ideas where the leaks are and what we can do to solve it. In this case, customer had offered up with their leak detection tools that this breaker was leaking through those guide pin holes. It's where they put a rod on there to guide the internals of that breaker to take it out for maintenance. SF6 was leaking through those holes. So a simple solution, well, just plug the holes. Well, then you do that, it's going to migrate around that the rest of that flange. So this is the flange that we needed to tackle to enclose around. Some crazy interferences to do that, because not only is it the flange that holds that end of that breaker together, but it also supports the pole to the structure that it sits on. And to add to the excitement, the middle phase pole is one way, and the two outboard poles, that configuration for that little ear there is offset by about 30 degrees. So each clamp would have to be different. The only one that was leaking was the center phase pole, B phase pole. So we fabricated a clamp to go around. You see, we did plug those guide pin holes. And okay, I don't have pictures of it here, but we did put those hollowed out bolts or nuts on the back side to contain the leak there too. GIS bus has got flanges, and yes, those leak. We can create a clamp to go around those for you, just the same as all the other stuff. And here's another picture of those. So that's kind of my story, and I think I'm good for some questions now, Randy.
Okay, well, I have a couple of questions. First one we got was, is there a limitation to a temperature limitation to these seals?
No, not really. Like I say,
these seals will work in any temperature with like -50, +50.
We have effectively contained leaks on components from the Arizona, Texas, up to northern Canada, with no issue. The sealant they do, you have two different. There's what they call a fast cure and a slow cure sealant. That the fast cure is typically used in the colder climate, so that it'll cure before it freezes. And ideally, we like to heat it. We'll put either a heat blanket or try to put a salamander in a tent up of some sort to keep the area warm, more so for the fingers of the poor guys doing the work.
Oh, sure.
But once it's cured, temperature is not an issue, either high or low.
Okay. Next question. If a leak happens and is repaired, does it depend on the quality of sealing when the leak will happen again, or once the leak happens to this repair, should it be expected regularly?
Inspecting regularly, I mean, a good due diligence for any utility would be to be routinely inspecting their equipment, even if it's been repaired, to see if it is leaking again. We will come out and reshoot if it does leak again. As you saw that one real rusted clamp there, we've had clamps on bushings like that have lasted effectively for over 20 years. Not to sound like a commercial, but we do offer a 4-year unconditional warranty on our work. So anytime within that four-year window, we're back to repair it. And if it's outside of that, we'll still come out and be more than happy to shoot again. But the percentage of reshoots and failures is pretty low.
Yeah. What are the famous and most popular reasons for leaks? Does it rely finally on the gasket? Is the gasket the issue when it comes to leaks?
Most of the time. Typically, yeah, that's what we're addressing, is gasket failure. You know, again, what we're doing is we're emulating the gasket either by going in and regasketing, going into a cavity with the drill and inject where the existing gasket has failed, or we'll create an external gasket pocket on the outside. And I would say 90% of the time, repairs, 99% of the time, the repairs are failed gaskets. I've got some crazy war stories where we've been invited to do other things that have nothing to do with gaskets, but I'll save those for another time.
Okay. All right. Okay, I've just Okay, I've given everyone your presentation, and the email address is at the end there, as you can see. Let's see. Hey, that's great. Thank you very much for a good presentation. There's lots of interesting stuff in there, really detailed.
Oh,
Great.
you're very welcome.
Yeah, always good to see you.